Hello my dear IPE students, welcome back to NEET World channel. So here we will be discussing IPE first year chemistry part. Okay, so this is our chemistry booklet for your IPE exam. Okay, so for all Telangana first year IPE students, if you are having chemistry as your subject like all MPC and BPC students, so here we are discussing all the important IPE questions. I think you know there is a blueprint on which we can expect the questions according to the blueprint right now. So here weightage will be as per the blueprint here, so everything will be provided. So I hope you are watching our previous live sessions where I have covered the list of important questions from each chapter along with that paper pattern, and everything is discussed in the last sessions right now. And also I have covered LAQ questions. I have covered LAQ questions from atomic structures. Okay, from atomic structure, the next classification of elements is also covered right now. So next, this is first question of LAQ, this is second question of LAQ, and our third question is either from organic chemistry or it from chemical bonding right now, either it from organic chemistry or from chemical bonding right now. So today we will be discussing organic chemistry LAQ first, because we know more chances to come from organic chemistry, that LAQ comes from organic more specifically. Then after we will discuss into chemical bonding, because if this chemical bonding question is not in LAQ, definitely that same LAQ question comes in, that chemical bonding question comes in the SAQ 4 marks question right now. So I suggest you to watch, if you haven't seen these previous live sessions on this LAQs of structure of atom and classification of elements, you can just go to that live sessions and you can watch it after completing this session. Okay, so as of now we will be discussing this organic chemistry here. Okay, and guys, now you no need of worrying about materials, like where you need to get all these materials, no need of worrying that. So here we are bringing up the new book here. This is C60 book. So this C60 book contains all the important questions that is required to complete to score your chemistry 60 out of 60. Okay, right. Similarly we will be having for physics as well as biology also. Okay, and even it is for mathematics. If you are an MPC student, even it is available for mathematics students also. Now some of this portion, I mean some of these topics, I mean some of these booklets are already uploaded in our Med World app, where we have uploaded this in our Med World app. Med World app you can download from the Play Store and you can access this book. Okay, so for complete book, yes, within few more days it will be coming out. Okay, so we are launching it soon. So but you can access this book from our Med World app. You can make your preparation along with this class discussion. Okay, so every question that is given in this book will be discussed here, so that you can get your material done and your explanation also done. So now you are no need of looking for someone to help you out. So because we are here to give you complete clarity and complete understanding of the question. Okay, so whenever there is doubt in the question, you just mention in the chat box, mention in the comment box, that we will be going to cover either in the live sessions or in the upcoming sessions. Okay, right. Let us start our discussion on this. See here, if you look at the question, so these are the questions like organic chemistry questions. Describe the methods of preparation of ethane. See guys, most of the students, most of the first year student will scare for this IPE organic questions, because they feel if organic might be too much tough here. No, this is very easy and you can write it in a very simpler and easier manner than the other questions. Okay, I am going to make it out, so just follow the session till the end. Okay, so కొంతమంది పిల్లలు ఎలా కన్సిడర్ చేసుకుంటారు, ఆర్గానిక్ కెమిస్ట్రీ అంటే చాలా టఫ్, సో దీన్ని వదిలేసి విల్ స్టడీ అదర్ టాపిక్స్ అని డిసైడ్ అయిపోతారు. బట్ నాట్, see, you know organic chemistry is very easy, and you know there is sure shot we can get one question from here. Okay, so that's why I am coming up with this discussion here today. So now first question is what? Describe the methods of preparation of ethane. అంటే ethane ని ఎలా ప్రిపేర్ చేస్తాము అని అడుగుతున్నారు, అండ్ దాని ప్రిపరేషన్ మెథడ్స్ ని ఎక్స్ప్లెయిన్ చేయండి, డిస్క్రైబ్ చేయండి అని అడుగుతున్నారు. ఓకే, సో నౌ ఇట్ ఈస్ వెరీ సింపుల్. First of all, this is for 8 marks question now. So option like here A, B types are there now. So A is for 4 marks and also B is also for 4 marks. So total 8 marks right now. So now what are the preparation methods that can be followed to prepare ethane? So for ethane preparation, what are the methods they are asking? Very easy. So ethane ni ela prepare chestamani adugutunnaru. So I will tell you reaction by reaction one by one. So first one is Wood's reaction. What is the first reaction? Wood's reaction. Just listen here what I'm saying here, that will be more than enough for your answer writing. Okay, so first one is Wood's reaction. So in Wood's reaction, see, there are 3 methods I'm going to share you now. All these 3 I'm writing here so that you will get complete clarity. See, Wood's reaction means nothing ma. You take alkyl halide. Alkyl halide ni తీసుకోవాలి. Alkyl halides means ఒక alkyl group ఉండాలి, ఒక halogen ఉండాలి. So treat this with sodium. What to treat? You just treat this with sodium metal. So this should be in dry ether condition. Dry ether condition లో తీసుకోవాలి. అప్పుడు ఏమవుతుందనంటే RR type of product వస్తుంది. ఇట్లా RR type అనేది వస్తుంది. అంటే ఏం లేదమ్మా, జస్ట్ లుక్ ఎట్ హియర్. నేను ఇక్కడ ఆల్కైల్ గ్రూప్ అంటే ఇథైల్, మిథైల్, ప్రొపైల్ అలా ఉంటాయి కదా. సో అలాంటి ఆల్కైల్ గ్రూప్స్ని ఒక హాలోజన్ ఆటమ్కి అటాచ్ చేసి తీసుకోవాలి. అంటే వెరీ సింపుల్ హియర్. సో ఫర్ ఎగ్జాంపుల్ హియర్ ఐఎమ్ టేకింగ్ CH3, CH2, Cl. So what you can call it as ethyl chloride right now. So you just take 2 moles of this ethyl chloride and treat this with a sodium metal, alkali metal, sodium metal. Dry ether means like dimethyl ether, like that you can take COCH3, like this you can take any ether. It should be mentioned as dry ether. What I am mentioning it as dry ether. అప్పుడు ఏమవుతుందంటే just remove this chlorine. How many ethyl groups are there? 2 moles we are taking now. So ethyl for one compound and another compound. Just join them so that we will get here CH3, CH2. ఇలాంటివి ఎన్ని తీసుకున్నాం? 2 తీసుకున్నాం కదా, రెండింటిని జాయిన్ చేయండి. సో వీ హ్యావ్ టేకెన్ 2. సో జస్ట్ జాయిన్ ద 2 alkyl groups, CH3, CH2, again CH2, then next CH3, like this. So your starting material are having 1, 2 carbons. ఓకే, ఒక కాంపౌండ్లో 2 కార్బన్స్ ఉన్నాయి కదా. సో అవి జాయిన్ అయినప్పుడు ఎన్ని అవుతాయి? 4 అవుతాయి. సో వీఆర్ గోయింగ్ టు గెట్ ఎ 4 నెంబర్ చైన్ హియర్. సో స్టార్టింగ్ మెటీరియల్ హ్యాస్ 2 carbons. So the product should have 4 carbons because these 2 carbons only coupling and to giving this final product. To give this final product, these 2 alkyl groups are coupling to form this final product right now. So the given alkyl group contains 2 carbons, the product contains 4 carbons. Just make double it. Okay, that's it. So this is what you need to know. So just read the definition now. See, when methyl iodide, it means any alkyl iodide you take or alkyl halide you take, methyl iodide is heated with sodium metal. Dento heat chesamanta sodium metal in dry ether. So when methyl iodide is heated in a sodium metal in dry ether, ethane is formed. So you are taking methyl. So methyl contains how many carbon? Methyl contains 1 carbon only na. So one like alkyl group is containing only 1 carbon. So double it, it means ethane will be produced here. So here methyl iodide plus sodium gives ethane. So here I mentioned you complete reaction of Wood's reaction I have mentioned. But in the question what they are asking? They are simply asking preparation of ethane right now. So preparation of ethane means you no need of taking all this. Just take a methyl iodide. I have explained Wood's reaction first. So now using Wood's reaction, now we are preparing our ethane. So take methyl iodide. So 2 moles you take, whatever the methyl group you are taking, just they will join, they will couple each other and gives ethane. That is nothing but CH3. That is nothing but CH3 attached with 1 more CH3. This is nothing but our ethane only now. So this kind of reaction is happening here in the Wood's reaction. That's it. So this is one of the method to prepare our ethane. Okay, right. And the next reaction we will see. And the next reaction here I will be explaining now. Right. So those students who are in live session, please tell me everything is clear now. Yes. So let me explain you few more things. Those who are in the live session, please respond. Look at this. Look at this. The next reaction here is decarboxylation. So what do we mean by decarboxylation? Again, let us take it separately and we will understand it. See, there are only 3 reactions you need to remember. First one is Wood's reaction, next decarboxylation, next coal-based electrolysis. These are the 3 reactions used to prepare our ethane here. Okay, in this particular exam you need to mention these 3 reactions and you will get good marks here. Okay, so since it is a 4 marks question only, yes, it is enough to mention this many reactions. See, decarboxylation means decarboxylation. It means you are removing CO2 gas. What you are removing? CO2 gas you are removing. From where you are removing? So you are taking carboxylic acid. What you are taking? Carboxylic acid you are taking. Like carboxylic acid means like this. I am taking an example, acetic acid here. So you just treat these carboxylic acids with soda lime. It means NaOH plus CaO mixture. Soda lime, NaOH plus CaO mixture. This mixture is called soda lime. Soda lime. Okay, so this soda lime will remove this CO2 from here. So what to do? Just mention this, and a heating condition you mention, like delta represents heating. Okay, so from our starting material, this CO2 part goes out. Okay, like C2 oxygens, that's it. CO2 is removed. What is the remaining part? Here you have CH3 and here one hydrogen, that's it. So this is methane is produced. Okay, what we are removing here? CO2, like this. CO2 is removed. So what you prepared here? Methane you prepared right now. Similar to this, we need to prepare ethane. So it means what we need to take? See, one carbon is removed out. So here if it is methyl, you are getting methane. If it is ethyl here, you are going to get ethane. Na? So that's it. You got the reaction. It means what to take here? You need to take propanoic acid. You need to take propanoic acid to prepare the ethane. So just take here CH3, CH2, COOH. You just take this COOH. Okay. Now just treat this with soda lime, NaOH plus CaO. So what happens, tell me? So just remove this CO2 part. What is the other part here we have? Remove that CO2 part, this part. So what is the other part here? We have ethyl and hydrogen. So add that things whatever the remaining here. CH3 is there and next CH2 and this hydrogen. So this is nothing but CH3 is nothing but ethane only now. Yes, you got our ethane product. So that's it. See, ethanoic, like ethyl group is there, one carboxylic acid. So you can call how many carbons are there? 2 plus 1, 3 now. So you can say it as propanoic acid. Propanoic acid. So propanoic acid, upon treating with soda lime under heating condition, gives ethane. What it gives? Ethane will be produced. Okay. So here it is mentioned as sodium propanoate. No issues whether it is sodium propanoate or propanoic acid here. No issues, because propanoic acid, upon treating with this sodium hydroxide only, it is forming this sodium propanoate. So sodium propanoate is heated with soda lime, giving ethane. What it will be giving? Ethane. That's it. This is the reaction. So in the starting material you have 1, 2, 3 carbons. CO2 is removed, so that you are removing one carbon, so that you will get 2-membered ring, that is 2-member chain, that is ethane only. Na? Yes, ethane is your product. That's it. This is the another way you need to understand the concept. Okay, right. Next one here is, you need to understand one more reaction, that is coal-based electrolysis. What is this? Coal-based electrolysis. I will explain this coal-based electrolysis. As of now, decarboxylation is clear or not? Yes, if this discussion is clear, just click on the like button, guys. Those who are in the live session, just click on the like button if this discussion is clear. Yeah, the next one here is coal-based electrolysis. What is this coal-based electrolysis? Just I am erasing this. See, please make your notes so that you can refer that notes for your final exam. Okay, right. See here, coal-based electrolysis says that, see here, read this one, sir. Electrolysis of aqueous potassium acetate forms forms ethane at the anode. It means I will tell you clear cut explanation for this, just listen here. You are doing electrolysis. What is this electrolysis? It means you are passing some electricity through this solution, and that solution, whatever the starting material you are taking, this one, so this is giving us our final product. So it means here I mentioned it as acetate ion, potassium acetate or sodium acetate solution you are taking in this beaker. Let us say sodium acetate or potassium acetate is taken here in this beaker. Okay, so this is acetic acid, like acetate ion and potassium ion, like this we are taking. Now during the electrolysis, it means we are passing electricity through this solution. Now what happens is, when this electricity is connected, like rods are dipped in it, so we get two things, one is anode, another one is called cathode. So at anode it has a positive charge. Anode has what charge? It is a positively charged electrode. So whatever the negative part present in this goes to this anode. What is the negative part here? You are seeing like carboxylate ion, like CH3COO minus na. So you write this CH3COO minus at this anode. Okay. Okay, this anode we are having. Now at anode this negative charge species is going, and one more electrode, one more rod will be there, that is called cathode. Okay, so cathode attracts cation, it will be having positive charge. Now what is the cation? Here you have K plus ion you have, and along with this, see aqueous solution we are taking now, aqueous potassium acetate. Aqueous means what? It is water now. So water contains H plus ion, that H plus ion also goes to this cathode. Okay, so K plus ion from this potassium acetate and H plus ion from water, that is nothing but H2O I am writing. Okay, so write, these are the things you need to write here. For understanding purpose only I am making like this. Okay, so now what happens is, at anode when we pass this electricity, the breaking of this electrons takes place, like lysis we are saying na, electrolysis means you are breaking, electron breaking. So it means you are breaking these electrons so that it will be giving CH3CO, O minus. Here O minus is there now, it becomes O radical like this, one dot means one electron, like this it will be forming. Okay, so one electron is coming out and one electron is stays there only. So now here this O dot is there now. So now what happens is, see CO2 gas goes out. See one dot is there, one dot means one electron. So here in this bond again one more electron is taken from this bond and one electron from this oxygen will be pairing up and going out as a CO2 gas. Okay, and what is remaining part out of this like bond, it means two electrons, one electron is taken this side and you have CH3 radical like this. So like this we will get, if I take n number of these molecules, we will get n number of these radicals right now. So all this will combine with each other and you will get a CH3 like this. So what is this? This is nothing but ethane only, no? Yes, your product ethane is formed. Okay, right, where it is happening? At anode. That's why they mentioned electrolysis of aqueous potassium acetate gives ethane at anode, ethane at anode, ethane at where? Anode. That's it. This is what you need to be mentioned in the exam. Okay, clear now? Guys, is this clear or not? Yes, I hope it is clear. If this is clear, just mention clear in the chat box. Okay, so now let me complete the reaction, because during the exam if you present in this way you are definitely going to get full out of full. Instead of simply mentioning the reaction, I mean like this, if you mention in this way, definitely examiner, like question paper, like whoever correcting the paper will get impressed and gives full marks. Okay, so now what happens here? At cathode what happens is reduction is taking place. It means what? Whatever the electron released at the anode, here one electron is released now, like that whatever the electrons released at the anode, that electrons are taken by this H plus ion coming from water and releases as H2 gas, forms a H2 gas. So reduction takes place at cathode, oxidation takes place at anode. This is what you need to mention, and these reactions if you mention, yes, this is really well and good. If you are feeling difficulty to mention all these things, you just mention this chemical equation. What they mentioned here? See what they are mentioned here. So like a potassium acetate, here potassium acetate upon electrolysis giving, see here see just ఇది చాలా easy అమ్మా. How many carbons are there here? 2 carbons. Now this CO2 group is going out. It means what is the other carbon fragment we have here? CH3. Like that, if we are taking 2 moles, we are getting 2 CH3 units now. We are going to get 2 CH3 units. How many CH3 units? 2. This is 1 CH3 and 1 more CH3. So between these 2, we are going to make a bond. That is nothing but our ethane is produced here. That's it. This is what electrolysis happens. This is how electrolysis product is identified. Okay, right. Hope it is clear. Now how you will write in the exam? Potassium acetate upon electrolysis gives ethane gas at anode. Okay, that's it. This is about the coal based electrolysis. I hope 3 preparation methods are clear. So just tell me once again what are the 3 methods. First one is Woods reaction, Woods coupling reaction. Second one is decarboxylation, and third one is what? Third one is coal based electrolysis. Hope these 3 reactions are clear. So now what you need to do? Just pause the video and try to understand, try to write these reactions directly now without looking at anywhere. Just pause the video and try to write these three reactions now. Okay, if these 3 reactions are completed, let me move forward with one more discussion. Like next one is second B question is what? Chemical properties of ethane they are asking. First they are asking preparation methods, then next they are asking chemical properties. Now how do you write the chemical properties? Tell me what are the chemical properties it has? What is the chemical properties it has? Just look at these chemical properties of ethane. So first one, action with chlorine. So it means we are adding chlorine to our ethane. So it means ethane means you write the structure like this, CH3, and to this we are adding chlorine. So chlorine you are adding. So what happens, tell me? So this happens in presence of sunlight. Sunlight may be also mentioned as H nu. Okay. So see, in presence of action with chlorine, ethane with chlorine you can write. Action of chlorine on ethane. So in presence of sunlight or UV light, ethane reacts with chlorine to form ethyl chloride. It means very simple. You just take ethane, take chlorine and write sunlight here, and this is what happens is one hydrogen of this ethane will be replaced with this chlorine. So it means you are going to get ethyl chloride, CH3 CH2 Cl, ethyl chloride, plus one hydrogen from here, one chlorine from here, comes out as a HCl. That's it. This is your product formed. Okay. So ethane plus H2 gives ethyl chloride. What is this? Ethyl chloride plus HCl gas is released. That's it. This is what you need to be mentioned in the exam. That's it. Very simple now. The next, action with nitric acid. What is that? Action with nitric acid. What is the formula of nitric acid? It is HNO3. So ethane plus nitric acid gives nitroethane. What it gives? Nitroethane. Here also very simple. So just whenever you see nitric acid, so remove one hydrogen from here and add that nitro group to this ethane. That's it. It is giving nitroethane plus water. Okay. So now these are the 2 reactions you have studied till now, right now. So make a note of these 2 reactions in your notes. Everyone who is in live session or recorded version, just make the note of these 2 reactions first. Yes. And after this, we have one more method of reaction here, one more chemical property, that is ethane polymerization. Okay, here it is combustion. Okay, polymerization, next reaction we will discuss. Action with oxygen. It means what we are doing? Combustion of ethane, C2H6, combustion of ethane, C2H6 plus O2. What happens? It undergoes combustion. What happens? It undergoes combustion. See, definitely hydrocarbons like carbon and hydrogen only there na. So you are going to get CO2 gas. What you are going to get? CO2 gas plus H2O. See, hydrogens converts into H2O and carbon converts into CO2. How many carbons are there? 2 now. So you write here 2 CO2. How many hydrogens are there? 6 hydrogen atoms. So here already 2 is there, multiply that with 3 H2O, that's it. Like this you can write. So again, for this, how many oxygen atoms are required for 1 mole of ethane? So just check here, 4 oxygen atoms, and here plus 7 plus 3 oxygen atoms here. So total 7 oxygen atoms we require. But if I write here 7, it will become 7 to the 14 oxygen atoms becomes, so I am writing it as 7 by 2 O2. So that 7 oxygen atoms here also 7 oxygen atoms, that's it. This is how you need to write a balanced equation during the representation in the exam. Okay. So oxygen, ethane on burning with oxygen gives CO2 plus H2O, and along with this some energy is also released, that is what heat of combustion we are saying. Energy is released, that energy is used for other purpose. For example, we are using hydrocarbons as our fuels right now. Yes, so due to its releasing nature of, it is releasing energy now during their combustion, so that energy can be used as a fuel, okay, for doing some work. That's why we are calling this as a fuels also, okay. Remember this statement. Next, look at this. Look at the next question here we have. First question is done. Second question here, explain 2 methods of preparation of ethylene. How do you make preparation? How do you prepare this ethylene? What do we mean by ethylene first? So ethylene means a CH2 double bond CH2. Ethene also you can call. Okay. The next B question is what? Write the reactions of ethylene with these things. First reaction with ozone, next reaction with hypohalous, next reaction with cold KMnO4, and the next oxygen. These are the 3 things they are asking. Okay. So similar to the previous question what they asked, preparation methods of ethane. First they asked about preparation methods, the next chemical properties of ethane they mentioned right now. So now preparation methods of ethene, okay, and next chemical properties of ethene they are asking. Okay, very simple. Look at here, just follow this. Okay, here first one is from ethyl alcohol. What is that? Ethyl alcohol. It means we are removing alcohol, we are removing OH group of alcohol by using one hydrogen from an acid. It goes out as a water, water, that is nothing but dehydration we can say. Removal of water is called dehydration. So look at here, ethanol when heated with concentrated sulfuric acid. With what? Concentrated sulfuric acid. What is the temperature here used? 170 degrees Celsius. Or we can also use alumina, Al2O3. This is a dehydrating agent. At what temperature? 350 degrees Celsius. Gives ethylene, that is nothing but ethene. Okay. So now look at here, I am writing ethyl alcohol. So ethyl alcohol means you can simply mention CH3 CH2OH. Okay. So now from this position, this OH group attached carbon is called alpha, and the next adjacent carbon is called beta. So alpha beta elimination you are making. See, from alpha position you are removing OH, from beta position you are removing hydrogen as a H place. That gives you ethene gas, okay, ethene product. Okay. So ethyl alcohol with sulfuric acid at 170 degrees Celsius. What happens? OH from here, hydrogen from here removed, and giving ethene as your product, and write that water as a byproduct here. Okay. So this is a beta elimination reactions. What is that? 1,2 elimination or beta elimination reaction. That is what? From where we are removing beta, proton is from beta na, so you can write beta elimination, remove of proton hydrogen from beta. That's why you are saying it as beta elimination, or you can say alpha beta elimination, or simply 1,2 elimination also we can say. Okay. So in the chart box, Anu, hello Anu. Yes, Anu, are you following the class? Yes, then next we will discuss few more things similar to this, again elimination reaction only. This is called elimination reaction of elimination of water from alcohols gives alkenes, like ethene is formed here. Similar to this, we can also make preparation of ethene from ethyl halide. From where? Ethyl halide you can take from ethyl halide by dehydrohalogenation. By what method? By dehydrohalogenation produces ethene. Okay, so just take ethyl bromide. See here CH3 CH2 Br ethyl bromide with KOH. Okay, alcoholic KOH. Upon heating, it will be removing beta proton from here and halogen from here. I will show you the reaction. Gives ethene. So ethyl bromide when heated with alcoholic KOH eliminates HBr and form ethene. Okay, so just write here reaction CH3. I am writing CH3 like this, CH2 and hydrogen here and CH2 Br here, like this I am writing. So now what happens is, here we are taking a base now, KOH is a base under heating condition. So now this base will take this proton, abstract this proton, and this bonded electrons are there now. So these bonded electrons are there now, comes here and bromide ion goes out. So what is forming here, just tell me. CH3 like CH2, this already a sigma bond is there, CH2, here bromide ion went out and here hydrogen also removed, so that you are getting here a double bond like this. Okay, so one sigma, one pi. So what you can say, that is ethene only na? Yes, this is your final product in the reaction, that's it. So this is what you need to mention in the reaction in the question exam. Okay, so is this clear? Is this clear? Next look at this next question, reaction of ethene with ozone. So we can simply call it as ozonolysis reaction. What is that? Ozonolysis reaction. It means ethene or ethylene react with ozone. It reacts with ozone to form ozonide. What it will form? Ozonide, which on reduction with zinc water gives formaldehyde. Okay, it is very easy ma, just look at here. So I will tell you first of all I will tell you complete product formation. See, ethene means this one known in la, ethylene or ethene means like this. So what we are doing? Ozonolysis. You can add ozone. So here you need to use zinc. So zinc act as a reducing agent here. Okay. Now what happens is, just break this double bond like this. If you break the double bond like this, what are the things we are going to get? See, one hydrogen and other hydrogen like this for this side, and this side also same thing is getting now. So you just put breaking, after breaking you just insert one double bond over here. So what it is forming? C double bond O H, C double bond O H. Okay, like this we are getting. So like the same thing happens at this side, same thing happens at this side also now. So 1 mole of ethene forms 2 moles of formaldehyde like this. Okay, so because one molecule is getting divided into 2 equal halves and giving this kind of things right now. How many are formed? This side one, this side one. So you are getting 2. Okay, what is the name of this product formed? Formaldehyde. What you can call? Formaldehyde. Okay, this is what? Formaldehyde. Okay, so ethene giving formaldehyde, ethene forming formaldehyde. So during this reaction we will be seeing something called ozonide. So what do we mean by ozonide? See here CH3 CH2 I am writing like this. How it is forming? See, ozone is there now. Actually ozone structure will looks like this. O minus O, like this, double bond here plus charge here. Okay, so when it is like this, so this oxygen will take these electrons like this, it will be making a cyclic 3-membered ring that will be rearranges in this manner. So what is the name of this compound? I am saying ozonide. What is that? Ozonide. Ozonide. Okay, first malozanide, then next ozonide. So this ozonide, upon treating with what? Zinc. So zinc, when we treat this with zinc, what happens is it will breaks in this manner. Okay, so this oxygen with this carbon and this oxygen with this carbon, and this middle oxygen is there, that is taken by zinc and forms zinc oxide, ZnO. That's it. This is a product formed during the reaction. Ozonolysis reaction product is this one. Okay, is this clear? Formaldehyde is a product formed upon ozonolysis of ethene. Okay, CH2. Okay, clear now? Right, guys, is this clear or not? If it is clear, just mention in the chat box. And after this, we have few more things here. Hope it is clear now. Let us remove this and we will move forward. Yeah. So what is our B? Next one is reaction with hypochlorous acid. Hypochlorous acid means HOCl. HOCl is called hypochlorous acid, HOCl. So here you can break this compound into this manner, like OH minus Cl plus. Okay, because oxygen is more electronegative than chlorine, that's why it is OH minus and Cl plus. Okay, so you need to add this HOCl to ethene, like you need to add this to CH2 double bond CH2. So what happens here? So on one carbon you add Cl plus, and other carbon you add OH minus, that's it. Why we need to add like that? I will tell you, just follow here. Why we need to add like that? See, we are getting positive charge on this chlorine now. So positive charge on chlorine is unstable. So it will take electrons from here. These pi electrons are taken by chlorine. So if it is taken by chlorine, so this carbon will lose its electrons now. If it is losing electrons, what is the charge? We need to indicate positive charge. That's why we are adding OH on this positively charged carbon and this Cl plus on this another carbon. Okay, so first we need to add chlorine here on one carbon like this, and on this carbon you are getting a positive charge. On that positive charged carbon you add OH. That's it. This is how you can make the reaction. Okay, so clear now? Is this clear? It is, I am giving this the way you can remember easily. That's why I am writing that on one carbon you add OH and on other carbon you add chlorine. That's it. That will be your answer. See, CH2OH and CH2Cl. That's it. This is your final answer. So addition of HOCl across the double bond gives ethylene chlorohydrin. What you can say? Ethylene chlorohydrin. That's it. That is your answer for the question. Next, after this, few more things we will be discussing. The next third reaction here I am saying is oxidation with Bayer's reagent. What do we mean by that? Oxidation with Bayer's reagent. It means we are using Bayer's reagent. What do we mean by Bayer's reagent? It is nothing but cold dilute alkaline KMnO4. What is that? Cold dilute alkaline KMnO4 is called Bayer's reagent. So now what happens is very simple, no need of confusing or anything to get tensed here. See, just take ethylene molecule. First you write ethylene CH2 double bond CH2. This is ethylene. Okay, so to this we are adding cold dilute KMnO4. What we are adding? KMnO4. So simply you can also call it as Bayer's reagent, cold dilute KMnO4, or you can simply say Bayer's reagent. Now what happens is very simple ma, you just remove this double bond, add one OH here, another OH here, that's it. So CH2, you can add one OH here and another OH here. So this is nothing but ethylene glycol. This is called as ethylene glycol. Ethylene glycol. Okay. So now once again read this statement what they are saying. So ethylene is oxidized to ethylene glycol when KMnO4 is added to ethene, that will be converted into ethylene glycol. This is the formula of ethylene glycol. CH2OH, CH2OH. Okay, right. Next. Now you know one more thing here, you can remember KMnO4, I think you seen in the laboratories, that is KMnO4 is like purple color or pink color we can say. The pink color of KMnO4 disappears. What happens during this reaction? At the beginning of the reaction, when we are adding KMnO4, it will be having pink color, but once the reaction is taking place, that complete KMnO4 is consumed, right? So it means its color will get disappeared. So this product formed will be confirmed by looking at the color change of this KMnO4. Initially it will be pink. Now what happens once after consuming this KMnO4, its color get disappeared right now. So that is what pink color of KMnO4 get disappears. We can call this as Bayer's test also, because this is Bayer's reagent now, so we can say it as a Bayer's test also. Okay, that's it. This is about the reaction. Okay, and the next one is polymerization reaction. So polymerization means nothing but you are heating this CH2 ethylene with O2, with what? O2. So here you can say oxygen is an initiator, radical initiator here. Okay, so it will form radical and will it initiate the reaction. But for this reaction you require high temperatures like 200 degrees Celsius and very high pressures like 1500 to 2000 atm pressures. Okay, then what happens? Whatever the ethylene is there, like CH2 double bond CH2 group is there, that will be converting into by like polyethene. Okay, so you will get CH2 like this, you will get a polyethene like this, N number. Okay, this is what the indication here, polyethene is produced. Okay, okay, so is this clear? So at 200 degrees Celsius and 1500 to 2000 atm, ethylene undergoes polymerization to give polyethene. So you got a polyethene kind of product, that's it. So this is one more reaction to be remembered. Next, after this I will be explaining few more things. Is this clear up to here whatever we discussed? Now just look at the conclusion. Ethylene can be prepared by dehydration and dehydrohalogenation. Yes, these are the preparation methods of ethylene. What is that? Both of them are elimination methods, like by dehydration of alcohols gives alkenes. It means ethyl alcohol upon dehydration gives ethylene, that is ethene. Okay, and also ethyl chlorides or ethyl halides upon dehydrohalogenation. Dehydrohalogenation, it means removal of hydrogen and halogen is called dehydrohalogenation, gives ethene, that is ethylene. Okay, this is also clear. And the next, it shows, it means ethylene shows addition reactions. Which type of reactions? Addition reactions with ozone as well as HOCl3, hypochlorous acid, as well as KMnO4. Okay, it shows addition reactions with ozone, HOCl3 and KMnO4. Okay, and polymerization reaction at a high temperature. Okay, so this line says about chemical reactions of ethene, and this line says about preparations of ethene. Okay, next, so these reactions confirms that its unsaturated nature. So whatever these reactions we have seen, Why that reactions are shown by ethene, why not by ethane? Because ethene is a unsaturated compound. What do we mean by unsaturated compound? If it contains at least one pi bond, then you can say it is unsaturated. See here, along with the sigma bond, we have a pi bond here in ethene right now. So due to the presence of this pi bond, ethene is showing this reaction, this addition reactions. Okay, hope this is clear now. So everything, every point to point, pinpoint to point, everything is explained, I hope. So now see, I am not using too much difficult things. I am using simple English to understood by every person. So be patient and listen to me carefully and learn the things. Okay, right. So everything is clear now, whatever we discussed, right? If this is clear, just mention clear in the chat box, and we'll move forward now with one more question. Here one more question here, just look at here, give two methods for preparation of acetylene. So what do we mean by acetylene? So it is nothing but C triple bond C H, and explain its reaction with water and ozone. Explain its reaction with water and ozone. Simple guys. First we have prepared ethane, then we have seen its chemical property. Next we have seen ethene, then its chemical properties. Now it is ethane and its chemical properties. Now out of these three questions, one question is for sure in the exam. Okay, one question is for sure. Whether it is, mostly it will be LAQ question only. By chance if it is missing in LAQ, that falls into SAQs. Definitely, for sure. Definitely you are going to see a question from this in your final exam. That's it. Okay, right. So yes, today's session is really helpful for all the students to score 8 marks in their LAQ part, in the section C part. Okay, so it means those who are watching this session, you can help your friends by sharing this video with them. Okay, if you have watched this, yes, after that you just share this video with them, because they can also get good understanding over this topic. Okay, and they can also score better marks. Okay, right. Look at this, what they are saying, give two methods of preparation of acetylene. So acetylene ni ela prepare chestamani antunnaru. So it is very easy. First one is industrial method. Okay, industrial method is nothing but you take calcium carbide. What is that? Calcium carbide. So take calcium carbide and hydrolyze it. It means దీనికి వాటర్ యాడ్ చేయాలి అంతే. కాల్షియం కార్బైడ్ కి వాటర్ యాడ్ చేసాం అనుకోండి, ఈథైన్ వస్తుంది ఇలా, CH, that's it. This is ethine. You can also call it as acetylene. Okay, so ethine also called as acetylene. So what I am saying, acetylene is prepared by hydrolysis of calcium carbide. Okay, calcium carbide ni hydrolyze చేస్తేనంట acetylene వస్తది అని చెప్తున్నారు అంతే. Okay, so this is the chemical reaction you need to mention. See, calcium means second group element na calcium, it will be +2 charge, and this is -2. So calcium carbide is converting into this format. So now out of this H2O, how many hydrogens are taken? 2 hydrogens. So you need to take 2 OH groups, that whatever the OH groups, that will form COOH twice, like this. Okay, so this is the reaction you need to remember for preparation of ethine from carbides, calcium carbides. Okay, it should be calcium carbide only. Okay, it should not be a magnesium carbide. Magnesium carbide won't give acetylene, it will be giving propine. Okay, the next laboratory methods. What are the laboratory methods? Look at here, dehydrohalogenation of dihalides. It means we are removing it means we are removing hydrogen halo, we are removing hydrogen halogens from dihalides. It means we are removing hydrogen halogen from compound having dihalides. It means, look at here, ఇప్పుడు ఇచ్చిన కాంపౌండ్లో మనకి ఏమేమి ఉన్నది, ఇక్కడ ఒక బ్రోమిన్ ఉంది, ఇక్కడ ఒక బ్రోమిన్ ఉంది కదా. సో ఈ బ్రోమిన్ని ఇక్కడున్న హైడ్రోజన్తో రిమూవ్ చేస్తాం, మరి ఈ బ్రోమిన్ని ఇక్కడున్న హైడ్రోజన్తో రిమూవ్ చేస్తాం. సో ఫైనల్గా we will be getting a product like this. So read this statement once again. When 1,2 dichloro or dihaloethane, what I am saying, 1,2 dihaloethane or 1,1 dihaloethane is treated with alcoholic KOH. What is that? Treated with alcoholic KOH. This is first step. Then followed by sodium. Followed by what? Followed by sodium in liquid ammonia produces acetylene. That will produce what? Acetylene will be produced. Okay, remember. So it means I will tell you each and every step here. Just see. CH2, CH2. Here we have one Br and one more Br here. So this one first treat with alcoholic KOH. Now what happens? This base abstract one proton from here. For example, I am writing these hydrogens like this. సో ఈ బేస్ అనేది ఈ ప్రోటాన్ని అబ్స్ట్రాక్ట్ చేస్తుంది, అంటే తీసుకుంటుంది. ఈ ప్రోటాన్ని తీసుకున్నప్పుడు ఏమవుతుందని అంటే ఈ ప్రోటాన్ని మాత్రమే తీసుకుంటుంది. అంటే ఇక్కడ ఉన్న బాండ్ ఎలక్ట్రాన్స్ ఇటు వచ్చేస్తాయి. ఇటు వచ్చేసినప్పుడు ఈ కార్బన్ మీద ఎవరైనా బయటకు వెళ్ళిపోయే గ్రూప్స్ ఉంటే వాళ్ళు బయటకు వెళ్ళిపోతారు, అంటే బ్రోమైడ్ అయాన్ గోస్ అవుట్. ఇట్ మీన్స్ బేస్ అబ్స్ట్రాక్ట్ అండ్ అసిడిక్ ప్రోటాన్ హియర్ and the sigma bonded electrons will be shifted this side. Therefore a living group from adjacent carbon goes out like this. So now what is the resulting species here? CH2 CHBr, and we are making a double bond here like this we made now. So this is our first one. Again now you need to treat this with a soda amide. Why we are using soda amide? Why not KOH only? Because soda amide is a stronger base than this KOH. That's why we are preferring this. Now this soda amide will take one proton from here. Okay, will take one proton from here, and that will be giving pi bond to this side, and this bromide ion goes out now. So we'll get finally CH and a double bond, like one more pi bond here. So what you got finally? You got ethine now. That's it. This is our final product formed here. See, this is our final product formed. That's it. So this is how you need to understand the discussion. Okay. Then next here we can treat same compound 1,1 like tetrahalo compounds. It means second method of preparation. See, dehalogenation, it means removal of halogens. Previously it is dehydrohalogen. One hydrogen is removed, one halogen is removed. But in this case only halogens. Dehalogens, it means only halogens. Whatever halogens are there, that will be removed. So here 1,1 2,2 tetrahalo, it means 4 halogens should be there. For example 1,1 2,2 tetrabromoethane is taken. What is that? Tetrabromoethane. It means CH. This is ethane. So to this you take bromines here. Bromine. So now just treat this with zinc. With what? With zinc. Now what happens? It will be eliminating this ZnBr. Okay, here also same ZnBr. So that we will be making a bond like this, CH, triple bond CH. That's it. So we are getting ethane as a product. That's it. Okay, reaction with acetylene. Okay, this up to here it is clear now. So you got to know preparation methods of ethane. Preparation methods of ethane. What are the preparation methods? Shiny in the gen shine. So yes, hi dear. Yes. So next what we have here? Next till now we like we got to know preparation methods of ethane. What are the methods we have seen? First one is industrial method. From calcium carbide, and the next one is from dehydrohalogenation using KOH, using alcoholic KOH and soda amide NaNH2. Okay, and third one is by dehalogenation using zinc with 1,1 2,2 tetrahaloethane gives ethine, acetylene. Okay, these are the three methods for preparation. Next one is reactions of acetylene. What we are doing? Reactions of acetylene. So what are the reactions shown by this acetylene, they are asking. Very simple, it is also reaction with water. It means hydration we are doing. So just take here CH, triple bond CH. This is acetylene or ethane you can call. To this we need to add water. What we need to add? Water. What we need to add? Water we need to add. So this happens in acidic medium, like H2SO4 is given, like some percentage, like 1%, 2%, like that, some percent might be mentioned here. Sulfuric acid you just take, and along with this mercuric sulfate is taken, HgSO4, that's it. So now what happens? So this compound will be now converts into CH3, C double bond OH. It means acetaldehyde is formed. What it is forming? Acetaldehyde is the product. See, in presence of mercuric sulfate and dilute sulfuric acid, acetylene react with water. Acetylene react with water in presence of sulfuric acid and mercuric sulfate. Okay. So first it will form vinyl alcohol, that is enol. Okay. Then which rearranges to acetaldehyde. So what we got? Acetaldehyde is formed. You can mention here it as acetaldehyde. Acetaldehyde. So if they ask, if you want, you can elaborate this by mentioning intermediate also. What is the intermediate formed here? So CH2 double bond COH H. This is the intermediate formed, which is vinyl alcohol, and tautomerizes to give this final product. Okay, tautomerizes to give this final product. So you can mention here tautomerism, so that you will get full marks for this question. Okay. So this is also clear na, reaction of acetylene. Next, reaction of acetylene with ozone. First one is reaction of acetylene with water in acidic medium. Now reaction of acetylene with ozone. Okay, that is nothing but ozonolysis we can say. What we can say? Ozonolysis. Now I will explain that. No need of worrying about this. See, take acetylene like this and add ozone. What we are adding? Ozone we are adding, O3. Okay. So now what happens is, you are going to get C, first it will form ozonide, here also it will form ozonide. So if I write here, yes, this is perfectly correct. Yeah. So write here C bond C, like previously we have did now ozonide in that alkenes reaction. Yes, same like that. You can write here also like this side one hydrogen and this side also one hydrogen. Now to this we are adding zinc and water. Zinc and water is added. So breaking like this it will be taking place, and this is removed by zinc, so that you will get a like a carbonyl compound like this. Okay, glyoxal we can say. So glyoxal is formed from acetylene. So just read that statement what they are saying. Acetylene react with ozone to form unstable ozonide. See, acetylene reacted with ozone forming unstable ozonide like this. Okay, acetylene as ozonide you can say, this is unstable. On reduction with zinc and water, ozonide gives glyoxal. Yes, on reduction with zinc and water, it is giving glyoxal. What is the name of this compound? Glyoxal. Glyoxal. That's it. That's it. This is what you need to mention in the exam. Okay. So yes, up to here it is clear now. So you have got to know the preparation methods of ethane, ethene, ethine, and the next chemical properties of ethane, ethene, ethine. So 3 questions are done. Mostly your 8 marks question is from any of this. Okay. If not, if we have some other questions, yes, there are few more questions like benzene formation from acetylene, these things are there, and chemical reactions of benzene, this is there. So tomorrow, in the tomorrow session, we will be discussing the remaining LAQ questions of this organic chemistry for your first year IPE exam. Okay. So hope you liked this session and you have really learned something new and you got more confidence and clarity on these questions. Now if you want anything further, just mention in the chat box. We are definitely considering it and we are going to do that in the upcoming session. So thank you for watching. Please do not forget to share with your friends. Thank you.